Well, certainly we have amazing technology. We probably need to develop more technology for the total planetary defense hazard because Chelyabinsk was certainly a wake-up call regarding the threat from asteroids, but there are also comets, especially long-period comets, which present a different magnitude of threat because they come in at a more rapid speed, coming from a further distance, and they tend to be larger than the typical asteroid that might threaten us. And for that, a very new technology would need to be developed. Much more research, much more testing. It might not even be feasible in the end. But yes, there are certainly currently existing threats from rocks and dirty ice balls from outer space, which we could meet with current technology if we had sufficient political will, which in turn depends on having an informed, educated populace. This is a very recent phenomenon, but I think indeed Chelyabinsk did make a difference in that respect, that it was spectacular enough that it caught the attention of the media. And now, since asteroid and sometimes cometary flybys are in fact relatively frequent events, not only are they in fact more frequent, but our new technology of discovery has improved to such a degree that we're aware of more of them than ever before. All of these factors have combined to make the publicity of these events more widespread and commonplace. It's going to take time to launch any kind of effective deflection mission to prevent one of these objects, once it has been detected, from hitting the Earth. But I think what has been getting lost in the message here is that sometimes the detection will not be early enough for us to deflect an incoming object unless we have already got some kind of deflection infrastructure in place before the detection. And so that's why I would say we need to have at least two ongoing efforts simultaneously to enhance the detection capabilities and to enhance the deflection capabilities. Both of them are going on now. Again, there are many dedicated scientists and engineers who are doing this work, but they need a bigger budget. They may need a much bigger budget. Well, they have very good reasons for that, due to the amazing discoveries we have made about the planetary threat from asteroids and comets. We have learned things that do differentiate asteroids from comets as potential threats to humanity. And for example, there are far more asteroids in the immediate vicinity of the Earth than comets. Furthermore, we are likely to have much more time to mount a deflection mission against the typical asteroid once we discover it than against the typical comet. So in those respects, it makes perfect sense to focus on dealing with asteroids first, as it were. But I personally feel that the emphasis has shifted too far in the direction of defense against asteroids to the almost complete neglect of the threat from comets. And again, I can understand the reasons why this has happened. It will be much more difficult to deflect the typical incoming comet than to deflect the incoming asteroid. And again, there will be far fewer of these, objects, statistically speaking, than of the asteroids. However, all of these phenomena are completely random. The bottom line, as far as I'm concerned, and let me, acknowledge that this is a controversial position, but as far as I'm concerned, the bottom line has nothing to do with statistics if we're talking about an extinction size object, because the magnitude of this threat is, as big a magnitude as there can be. So even though you have a relative difference in the probability of a cometary threat and an asteroid threat, the fact that they're all random is all that matters in the case of an extinction possibility. So I would say there has to be more emphasis than at present on the cometary threat, but of course at the same time to continue all of the efforts on behalf of the asteroidal threat.